given this problem statement here, the product of three consecutive terms of a geometric progression is 512. If 4 is added to each of the first and the second of these terms, the three terms now form an arithmetic progression. So in that case, we need to compute the sum of original three terms of the given geometric progression, right? So now proceeding towards the solution. So we'll make an assumption, let the three consecutive terms of a geometric progression. So let these terms be, one of the term as a over r, the next term as a, and the other term is a times r. Now from this we can say the product that is given. So now we can say, now according to the problem statement, according to the problem statement here, we are having here the product here, that is a over r times a times r. This is equal to 512. Now from this we can mention, that is a power 3, that is 512, and this 512 can be written as 8 to the power 3. So a cube is equal to 8 to the power 3. Now here this is a cubic equation, hence it will have three distinct roots, right? Now the only acceptable value for this situation is 8, and I am neglecting the other two roots. Now proceeding towards the next step, also it is mentioned in the problem statement, if you observe here, that when 4 is added to each of the first and second of these terms, the three terms becomes an arithmetic progression. So now I will be using this particular information here, that is after adding 4 to the first two terms, we get, so we'll be getting the terms as, one will be 8 over 4, sorry, 8 over r, this r is the common ratio, right? 8 over r plus 4. The next term will be, that is 8 plus 4, 8 plus 4 over here, and the next term will be 8 times r. So on performing this operation, these are in arithmetic progression. Now following this part, now if we just follow this part, so from this one we can mention here that arithmetic for an arithmetic progression, the middle term is the average of the first and third term, right? So we'll be using this property here. So this implies that 2 times 12, this will be equal to 8 over r plus 4 plus 8 times r. Now on resolving this equation, so this gets 24, that is equal to the same given equation, right? Now in the next step, after resolving this, we will be getting here 2 times r square minus 5 times r, and here plus 2, that is equal to 0. On resolving this further, I will be getting here 2r square, this will be negative 4r minus 4r minus r plus 2, that is equal to 0. Now from this we can clearly observe, this can be written as 2r minus 1 times r minus 2, that is equal to 0. Now on resolving this, for r I will be getting the roots as, one of the root will be 1 over 2, other one will be 2, right? Now at this point 1 over 2 is also one of the answer, and 2 is also one of the answer. So from this we can say, thus the terms are either decreasing, that is 16, then 8, and then 4, because when you consider the common ratio as half, or it can be written as 4 or 8 or 16 when you consider the common ratio as 2. So you are getting increasing and decreasing accordingly, right? So hence we can say the required sum, that will be equal to 4 plus 18 plus 16, since addition is associative. So this sums up to 28, and for this problem statement 28 is the correct answer for this particular problem statement, and hence we have solved this given problem.